we're going to look at finding the area of regular polygons. This is on page 44 in your math notes, and it's on page 506 of your textbook. You don't have a picture or a formula for this. The formula varies from one to the next. So we're just going to put a summary. If a polygon is regular with n number of sides, it can be broken up into n isosceles triangles. These triangles can be used to find the area of a polygon. So our example is we want to find the area of a decagon with side lengths that are. So if we have our decagon, break our decagon up into equal isosceles triangles. From the center, we can connect to the vertices. And we could do this all the way on. And we would create 10 isosceles triangles that are all equal to each other. Now, we can find the area of a triangle. Do that. It's 1/2 base times height. If we can find out some information about the triangle, we already know that the base is 6 feet. Then all we need to do is find the height, and we'll be able to find its area. If we do that, we'll be able to find the area of all of the triangles. Since there are 10 of them, we will just multiply by 10 and find the area of this decagon. So I'm going to find angle at the top here. We know that all the angles at the center add up to 360 degrees. So this angle is going to be 360 divided, which is 36. Now I'm going to draw this triangle bigger so that we can see what's happening. So we know that the base is 6 feet. The angle up top is 36 degrees. And we need to find the height in order to find the area of this triangle. Since this angle up here is 36, and we're cutting it in half, we know that angle here is 18 degrees, and this angle here is 18 degrees. We also know we're cutting this base in half. This base here is 3 feet, and this piece is 3 feet. What we need to do is find the height now. So we have a nice right triangle with an angle at top of 18 degrees and a base of 3 feet. To find the height, we just have to use one of our trig functions, sine, cosine, or tangent. With the 18 degrees, 3 is opposite, and the side we're trying to find is the adjacent. So we're going to use tangent. So the tangent of 18 degrees is going to be equal to which is 3 feet, over our adjacent, which is the height that we're trying to, of 18 over 1, multiply to ratio. So h times the tangent of 18 is equal to divide by the tangent, and we find out that our height is 9.3 feet. So now that we know the height, we can find the area of one triangle. So that's going to be 1/2. The base of this triangle is 6 feet. We're using the big isosceles triangle. And the height is about 9.23 feet. So the area ends up being about 7.69 feet squared. Now, in our decagon, add a total of 10 of these triangles, because side will have a triangle that's associated with it. So we just have to take this value, multiply it by 10, and then we will have the area of the polygon. So the area of the decagon is going to be 27.69 multiplied by 10. The area ends up being 276.9 feet squared. And you can apply that to any regular polygon. Maybe won't give you the side length. It might give you the height, or it might give you the side of one of the isosceles triangles. You still can use that information using sine, cosine, and tangent, and also the fact that the angles at the center add up to 360 in order to find the other mids that you need. And once you've found the one triangle, multiply it by the number of sides and it'll give you the area of that polygon.